It's the usual questions. Who's used used an F# type provider? Who has written one? Okay. Used one in production or just
Production.
Cool. So I've not used type providers for a while, but I've not used F# for a while. And when I attempted to write a type provider, it was a mad science experiment I gave up because it wasn't really good enough, anywhere near good enough for production or even the prototype it was meant for. So that said, I'm going to try and explain a little bit about them. So they arrived in probably the best version of Visual Studio, Visual Studio 2012 with F# 3.0. There wasn't really anything done with them by the community until 2014 or so, as far as I can see. A lot of it was figuring out how the hell they actually worked and what it could use them for. And I guess there's not been much change to how they work since then, except a small modification to the way you can construct them to make it a little bit more convenient, and .NET Core breaking everything. So they currently don't really work on .NET Core at all. There's a hack that's meant to enable them, but I couldn't get it working on Linux at least. I'm sure it's actually possible. So what do? They provide types. They're a kind of code generation, so you might have seen them in other languages implemented as compiler plugins. So you can feed an abstract syntax tree into the compiler, and then you get the types. Macros are also a kind of crude version. Macros are also a kind of crude version of that. The main difference is that you have full access to your programming environment when you're creating them, so you can access internal data sources and run all sorts of code to generate the types for the provider. They're kind of useful in lots of situations where you have weak external dependencies on, say, definition for a REST service, or a CSV file, or even an XML schema or a database. So a lot of solutions to that, certainly around 2011, were to just take those schema files and then statically generate a bunch of code, and then use that code in your project. And those sort of approaches got a bit of a bad reputation, certainly for when people attempted to round-trip code generation, make modifications, or have a single process where you press a button on a database and it generates a website. But the implementation of type providers is a lot more specific and focused kind of code generation. They're also kind of dependent on a lot of Microsoft tooling. So as a Microsoft developer, you're used to having good IntelliSense and the ability to interact with a program as you're developing it. So I think it's kind of a natural fit for that this would have come out of the Microsoft development space rather than a lot of others. So you can build two kinds of type provider. There are generative type providers, which are very poorly documented and rarely explained, so I'm not going to either. But they essentially work a lot more like classic code gen. So you have your external data source, you generate all your types, and you feed those into the compiler. And obviously, there's no way to modify that after you've created them, but they're not erasing types. So an erasing type provider is probably misnamed because they do kind of erase types, but it's more that they replace the types. So the types that you're creating during their construction, when you're operating the IntelliSense environments are thrown away and replaced with another type. So it acts more like a scaffold where you're creating a lot of types in Fly, but then they're replaced by a far simpler one. So, and they can raise all the way to a primitive type like a string or an integer. This is mainly for dealing with very large external schema. Was the original idea, to be able to explore online data sources where you couldn't possibly generate all the code for, say, the semantic web version of Wikipedia, because especially if you wanted to use it for constants, you just have a ridiculously odd binary that contains all the data and schema that you don't necessarily need. So those taking a smaller dependency on an external resource or an external type or a protocol is generally a good idea. It means you're much less likely to break it when that changes, and especially if they're poorly defined. I mean, that was one of the justifications for hypermedia style in REST was to minimize the amount of dependency you have on the type of an external service. You get all sorts of issues with people naively consuming, say, a JSON API and depending on the order of the properties. And so other languages that do it, right, really. I think Idris does, but Idris terrifies me, so I'm not going to give any examples.
Sorry, I'm maybe having a thick moment, but I'm not quite getting the difference between generative type providers and erasing type providers.
Okay. I'm not entirely sure I can explain it very well. So, without showing some code anyway, so a generative type provider, you would just puts the types in that you've generated, but an erasing type provider allows you to replace that type with another one. So
does it do that at compile time or runtime?
it does it at compile time. So the runtime type is different from the compile time type, and you have code for replacing the compile time type with the runtime type.
So it's being sort of a proxy.
Yes.
Type that compiles.
Yeah, effectively. So one thing I'll show that was quite a reasonable example is if you wanted to create a string with bounded length. So your compile time type would be a string and the length as you're working on that, but you could erase that just to the string and protect that, and protect that with a constructor you can generate. But the actual type you would generate from the erasing type provider would be string. Whereas with a generative type provider, it would be string and the additional properties you needed on that string to enforce its type. Not sure I explained that very well.
It's fine.
So again, yeah, code generation had a horrible reputation, mostly for a good reason. There's people here old enough to use rational rows and all those kind of horrific round tripping tools. Certainly, a lot of early object relational mappers relied on code generation as well. It's okay. So let's try and demonstrate one with. See this. So the World Bank type provider primarily only exists, I think, to demonstrate type providers. And there may be data scientists who need access to the World Bank and use F# use this a lot, but I kind of doubt it. So what we have here is you see this? Yeah. What we have here is F# interactive setup with bringing in the F# data DLL. And then the World Bank data context. So, the joys of IntelliSense. Sorry about that. This is now internally gone off called an external web service, and generated this little menu of types, and it's done that by just generating a lot of properties on the type that that it's going to later erase. So if we go to Bulgaria city, and then evaluate this. So it knows the capital city. It knows the capital city of Bulgaria. So the difference, the thing here is this type is actually a string. So all the web service activity and everything else that's gone on to get to that point has been erased in the final execution.
So is it a generative or an erasing?
This is the World Bank one is an erasing type. That's primarily what it's because it's a huge data source. That's what its primary purpose is, to demonstrate erasing type providers. I think people might actually use it.
So I take it World Bank data is actually provided in F-sharp data. Is World Bank data provided in F-sharp data?
F-sharp.data does have the World Bank stuff in it, yeah. It's kind of weird that it's in there because it's one that's so the other ones in there are actually day-to-day useful, but that's the only reason I can think is it's there for demos. So useful ones. Most of the ones you'd want to use every day are actually in F-sharp.data. A lot of the ones out there are experimental, can we say? Not very well used. So I mean, if you're going to, you probably have to pitch in and modify them yourselves. And also in the F-sharp.data, there's a bunch of useful internal tricks in it. So can we see that? Okay, that's terribly small. So what we're doing here is defining a JSON provider with an example JSON object. So what this will do is infer a type from that JSON object, which you can then use. So in simple case, we can just feed that back. We can just feed that back to it, and if you IntelliSense, then properties it has on it is name in itself. But this provider does a bunch of nice things internally, which are actually quite useful. So you can see from the pop-up there, it might be a bit small, but it's figured out by example that number there is an integer rather than a string. So it's internally doing a bunch of tricks to figure out primitive values from examples. This stuff is not built into any of the type provider SDKs or anything. I think they tried to extract it from sharp.data, but it is kind of intrinsic to it. So
does it change the case of the real property thing?
the case is set by convention. So it's they're always capital letters. So if you put it anyway, if I do that, yeah, there it goes. But it will always try and make it look like a canonical .NET property. We start properties with capital letters in .NET, so usually. So I mean, this can also, you can do a bunch of other stuff with this. You can feed it. You can in fact feed it multiple examples, and it'll try and find the union of them that's the actual, to infer the actual schema from them, which is it can be kind of useful.
So what would it have done in that case? Because you were trying to find number.
Yeah, what I was expecting it to do was make that into a float, but it doesn't do much.
But if you actually executed the still got number.
All right. So in that case, it's going to be, in this case, it's going to be null because it's not in the example, probably. Yeah, that's right. Well, actually, no. It gave us a runtime error on the parse here, which is reasonable. I think there's also a way of saying which fields are null, etc., etc. Or if you had if you fed it multiple examples where one time the property didn't exist, it would allow it to not exist.
So all it cared about was what you told it in simple and capital
Yeah.
letters. It didn't care about the next one.
Sorry.
It didn't care that your simple, the lowercase s, hadn't got a number. All it cared about was the type definition you told it it did.
No, it did. So it actually crashed on when it tried to parse this here, because it only has the one example.
Oh, right, it doesn't look at that till runtime.
No, unfortunately.
Okay, right.
So it told us that number was missing because it's strictly a part of that JSON object. If we gave it a list of examples and one of those didn't have number, then it would allow number to be.
If a property in different objects had different types, would it create a union?
Yes, that's what it tries to do. So it would be integer or string if you found an integer or a string. So it also does similar stuff with CSV. You can imagine how this is going to work. So it takes a sample CSV. So this is Google Finance CSV. So it's got it has a date field and opening and closing prices. So it will infer that from the CSV file.
Just because it is the right height doesn't
Oh,
mean
yeah.
that the
So,
projector
yeah,
won't
some
be
CSV.
into it as well.
So the magic of internet access, you can see that it's it has gone online, fetched a bunch of CSV and interpreted it. So it's inferred the types just from a single line sample. So obviously it's got the property names from the sorry, too many windows. So it's inferred the property names from the CSV header, and again it's figured out the types using the same resolution tricks that the JSON provider does.
Are you able to give it any sort of hints if it's perhaps ambiguous?
Yes. Yeah. So it is because the F-sharp the data is actually used, so it does actually have features that you would encounter in reality rather than just in demos. So yeah, you can so we all know what bloody CSV is, right? So yeah, you can override its inference because it's almost certainly going to be necessary.
Can it work from a file rather than a URL as well? There's no problem. It doesn't have to be anything online.
So it's inferring from here, which is downloaded and static, and then it's loading the runtime from another URL. So yeah, it's best. In fact, I think it only works with local file access rather than a URL.
I was having a real problem the other day, and I never got to the bottom of it, where I had the same file locally that I was using for the sample and trying to load, and I had all the IntelliSets going just fine in Visual Code, but every time I tried to compile, it blew up in my face.
Right.
I never got to the bottom of that.
Yeah, that's a bit weird.
I was trying to do this in a user group, and I was trying to be clever, and it blew up.
It's usually when it's going to blow up. Right?
So does that mean that you can have maybe part-time dependency on something that's on the web? I mean,
Yes.
if you're offline.
If you're really adventurous, yeah. It's you'd probably want a copy of that on your local network at least. But yes, you can. So in the case of the World Bank provider, that is the compile time dependency on a remote source. It's got good availability. But I'm sure it's blown up in a lot of people's demos.
So presumably, they rely on the schema being fairly standardized Otherwise, you're going to write a bunch of code against it, and then someone decides to change it.
Well, it tries to discover what's going on. It makes some assumptions, but in theory, you could build a REST like you meant it. Type provider that attempted to do dynamic discovery from something approximating the live source. I think I don't think anyone's actually done it successfully. And that's why the SQL providers obviously dynamically discovering the schema, because that's what they need to do. So slightly less useful. Okay, there's also an XML provider in there, but I'm not going to demonstrate XML because nobody's really going to be thrilled by that. But it's actually, again, it's quite a practical piece. It's quite a practical thing. I've used it in production.
On the XML one, does it actually take a sample of XML or the schema?
Take samples of XML, but you can feed it XST as well.
Right.
I think that was added, but yes. But how many times have we had XST that actually bloody works with them?
Can you feed it to DTD just in case you're working with people who are even older than XSDs? Working with finance agents, I've had to face that.
Generate samples from DTD and then give it to the type provider. Yeah, but there's probably a way. But I mean, there's all sorts of like fancy ways of validating XML that would never work with the sort of approaches schematron and that. So yeah, it basically works by samples. So there's also an HTML provider, which is wouldn't say it's practical. It's kind of useful for quick and dirty web scraping, but web scraping stops being quick and ends up a lot more dirty. Right? So again, not sure how practical it is in production, but this is just fetching a page off Wikipedia, and so again, that's a live interaction with HTML with an HTML page in Wikipedia about that. It's printing something completely different to what it did yesterday, but that's the joy of web scraping, right? But it kind of looks like, you know, this kind of thing that would be in that web page.
Well, it's Wikipedia. If it would help, if you just go and edit it, right?
Definitely the best way to fix it down. It's probably a different list. References. Yeah, okay. This is slightly less shitty looking list. So yeah, I mean, that looks like a list of references of a Wikipedia page. So another one that's vaguely practical, and I think it's actually a generative type provider rather than a raising one. You know, there's a lot of complaints about it ever going to work on .NET ever again, because generative providers are apparently more difficult to port to .NET Core due to some obscure reflection dependency, those usual sort of issues. So there's a Swag provider, which is actually quite good, but again, I'm not sure the benefits it provide over other code generation approaches to access Swagger services, which everyone uses anyway. And the fact it works with F#. And no one can modify the code. But. So F#.configuration is actually quite practical, and I have you. This actually links to the wrong thing. That's a great professionalism. I actually deleted the F#.configuration demonstration and replaced it with a dependent type one for some reason. So, okay, the F# configuration, so I'll have to explain it with words. So the F# configuration type provider does kind of what you'd think it'd do, and it provides types for your configuration files. It can actually work with app config in a variety of other formats. So it could be potentially useful if you have multiple configuration formats, or if you wanted to migrate from one configuration format to the other, because you're only really dependent on how you're using the configuration file rather than everything in the configuration file and its format. Assuming it maps to one of the file types that the configuration file actually provides. So exotic ones.
So, since it's used to parse files in this format, is it able to actually render out to these formats?
Yes. Yes, so both the XML, they're all writable as well. They generate appropriate type constructors. So you get a row constructor for the CSV, and yeah, similarly for the JSON objects. So they're actually a better demo had actually been wiring a couple of them together, because I mean that's what they're really quite practical for, is fiddly data merging tasks that nobody really likes, and it does a lot of the checking for you and make sure everything lines up correctly. So yeah, converting. We used it for translating horrific XML documents into other horrific RDF documents, but so those kind of tasks, it's really quite decent, especially when there's no schema supplied. So exotic ones, the SQL providers probably count as this. I mean, they kind of work, but from what I've seen and heard, there are if you have large, well, normal sized enterprisey databases, they really do tend to slow down your compilation. And the benefits they provide over lightweight ORMs, not sure. But I'd be interested if anyone actually did try one anywhere near production.
Tried it, it failed for all.
Okay.
Yeah.
What were the reasons?
Really did, as you said, did nothing more than a lightweight ORM would do for me. Was generating relatively inefficient queries.
Okay.
Much better to use something lightweight ORM
We've had a lot
for the job.
Yeah, we've had a lot of bad experiences of extractions over databases, right? So even if they are a bit fancy, it's
I think there's, SQL was invented as a language to query databases with. Why don't we just stick with it?
so. Yeah, that's right, doesn't it? So this is not the configuration type provider. This is exactly this is more interesting. It's kind of incredibly incomplete, but it's a nice example of what you could potentially do with it if you really like metaprogramming. And then it provides bounded primitive types. It's not really a dependent type provider, but it can enforce regular expression matches on strings and ranges of integers and various fiddly little things. You see them a lot in the well, you don't see these a lot, but you see it done a lot in the domain driven F# examples with and that's just done manually. So this is a way of using type providers to enforce constraints on primitive types without having to do all the new type checks. Writing code, everyone wants to write code. So what we're doing here is defining a really bloody awful domain model where we length constrain the first name and the second name, and then we have we call that a bad type, and then we sorry. It's on the screen. And we write a constructor over that. So we'll take a first and a second name, and then it'll attempt to call the try-create method on these two bounded strings. If that succeeds, it'll return the bad type object. It doesn't return that. You probably want a result or something in practice. So it's managed to create Bob Smith because that falls within the ranges. But if I can try and create one with a slightly longer with a longer second name, it's bombed out in that process, and not actually return me a result. And you can see by the yeah, I've got the joy of that. Name. So even though it has these, the type that the type provider is using is bounded string, and you're adding all this additional validation. The actual runtime type is system.string, so it's erased all the extraneous stuff and the type you use to build it with, and just replace it with string after doing the validation. This also contains bounded integers and various other things. It's just a little experiment, but I thought it's kind of interesting for those sort of tasks. I can imagine it turning into a right horrific mess with the proper validation might be there. But.
So in a way, you've not actually got anything that's, you've got the kind of provider bits in there, it's just all.
Yeah, the provider bit's all gone by the time it's the magic of erasing, which is it's not, it erases things. It's more like replacing in practice. So there's a bunch of bloody ridiculous type providers out there, mostly written by a guy called Pezzy Pink. I don't know if you've ever seen him do F# demonstrations, but so he has a type. I couldn't get these running on mono because they were so he has a type provider that you can feed Z engine definitions, and it will turn into an adventure game for you. So you can actually type go north in as a property name, and it will take the Z engine. He's also got multiplayer TCP battleships that you can play via IntelliSense, which is just excessive, maybe. But if you can actually get them working, they make good demonstrations. Possibly not in work. So, because of Stephen Faulkman, there's actually apparently quite good dynamics nav support in via F# type providers, which is if you ever need an excuse to use F# in a dynamics nav project, there's a lot of good ones. So, but I mean, I'd say the only really practical ones are F# is stuff in F# data. I mean, there are ones that seem to be useful in data science and things like that, but I don't do data science. I don't think a lot of people who do data science use F#. And the primary type provider for doing that is interop with R, which is a nightmare to get. Which is also a nightmare to get running. So, have you ever felt like writing a type provider? There's some that are obviously missing, like attempting to basically properly do REST, but we've all given up trying to properly do REST. It's a bit too bloody hard, and I think a type provider would be particularly difficult with interacting with stuff unless you're using one of the JSON LD sort of sneaky semantic hypermedia formats that told you how you could actually interact with a resource, not just fetch it. I don't think the world needs another view engine, but I reckon you could probably write one with. You could probably write a nice one with, write a reasonable one using type providers, and just kind of reversing the way that you would have. You write DTO. You write a DTO for a view. You write your view, and then you write the your view code over the DTO. Is usually the way it goes. But there are other quite old templating engines like String Template, which is used in compiler generation kind of stuff. And they're pure push models, so they don't really have a model, but you write how they render, and then you could infer the model via a type provider. It's the kind of thing I'd do if I was still paid to piss around, but I'm not. GraphQL would seem to be a reasonable fit, but apparently it's really bloody hard, and it's been pulled out of the F# GraphQL libraries, which I guess is unfortunate. So, should you try and write a type provider? Probably not if you're getting. Probably not if someone's paying you. If someone's paying you by the hour. So, I mean, we've all been around the block a lot, and I mean, excessive metaprogramming and software development's probably got a lot of us in trouble, right? Not sorry, in trouble. It can be distracting you from what you're actually meant to be doing, and giving you a fictitious feeling of productivity. And it's potentially a lot excessive complexity to do something simple if you haven't called on the need to do it correctly. So if you are going to write a type provider for something, you need a bloody good reason to do it. It's very in commercial environment, that's a really good reason. They're really not amenable to any kind of naive association with test-driven development. They're very difficult to build incrementally, and you can only really test them by behaviour. I mean, if you're going to do pure unit testing with them, you'd be asserting on an expression. You'd be asserting on an expression tree and all sorts of horrible things you really wouldn't want to do. And I guess if you so the type provider I attempted to write was part of a mad scientist experiment at prototype of it, so I vaguely thought it was justified. So it was to do semantic web stuff, so we could have IntelliSense on RDF files and inputs and things. But I mean, I guess if you're doing a lot of data and doing a lot of data work, and you have Scheme authority, you've written parsers. It might be a nice way to access that, but it's only really if you have the core functionality that you can add a type provider to for some kind of benefit. You should probably think about doing it. And yeah, basically try not to. But as an open source project, go for it. There's probably only about 50 people in the world who've like written one that's vaguely successful, I think. So if you do actually want to write one, then you need the type provider SDK, which is basically just two source files. The easiest way to do that nowadays is with packet and get references. So the main file it brings in is frankly terrifying. It's probably best off in the small text. No one's going to read this shit anyway. So it is kind of scary. It's it goes on. We just go on. So it's 750k of F sharp. Right? 14,000 lines. So I assure you, I read and understood this file completely before I tried to write a type provider. So I mean that is pretty off-putting, and it's the interface file's not much shorter either. So you need that and the interface file.
Is that handwritten code?
Yeah. Grad students are really productive. So you need that, the NFS project, you whack it in. And then you have your type provider source. So actually working with that is not very functional at all, and it's all mutable type. It's all mutable types. It's really quite OO, ironically, and in using it you can I think it's semi-jokingly called the bridge of death. There's only a very limited set of types that you can actually squeeze through the compiler infrastructure that will come out again all right. So basically you need to the .NET 1 types, so straight up .NET types, no generics, no records, no discriminate unions, which is kind of a surprise when you And of course, all those nice tricks in F#data around primitive type inputs and things, caching, which I've got that. Yeah, you have to write a lot. The SDK is literally how to feed those types into the compiler. So to actually do that, you'll need to use F# quotations, which are pretty cool. And they're a lot nicer than C# expression trees, which if anyone's worked there, which are deeply unpleasant. So this here is a quasi quotation. So basically what they allow you to do is write a limited set of F# syntax with some little bits and bobs for substitution, which will actually, rather than returning the result of that expression, return to the expression tree. But you can do it both, except for all the horrible edge cases, just by writing some F#. F# inside that construct will return expression tree of that construct. It's useful in other places, obviously, other than type providers, but you tend to do a lot less reflection work in F# in general. So debugging type providers is so if you're using Visual Studio, you need 2 copies of Visual Studio running, which there's various situations to get them doing that, but because when the DLL is loaded into a .NET runtime, it's just loaded. You can't reload it, and you're constantly working on the internals of that. So you're stopping and starting IDEs and killing interactive sessions all the time to get around that.
Can you use Visual Studio's added debugging stuff? Visual Studio's got really good support for debugging.
Oh, debugging its own adding. I'm not sure.
I've used it in the past. It's really good.
So the way I did it was just via F# interactive primarily, because it's easy to kill. So you can just restart it, compile your project, restart and F# interactive. So for actual tests, then you can spin up the F# compiler service and feed it an example, and you'll at least get the F# compiler service compiling bombing out an error if it doesn't compile. But it's not necessarily the best assertion. So you tend to also just have a lot of examples in FSI or F# that you assert with a unit test frame. So it gets even nastier if you try and support multiple frameworks, or if you actually have say a NuGet dependency from your type provider. It's not just system, because quotations stop working. So you need to generate 2 assemblies. So you split it. You'll see it with quite a few of the more complicated ones, that you'll have a design time assembly, which is the actual type provider stuff, and its runtime components separately. But that breaks the simple use of quotations, and you have to do horrible things to rewrite the quotations into the runtime assembly rather than the design time assembly. It's you can copy what other people have done. So I'm sure you've seen the OWL thing before. So I'm going to show you a Hello World type provider. Should I got these links right? Something like that. So, after you've brought in those 2 lovely files, then you can then write a type provider. So, I should probably go to the bottom first. So you need to mark your assembly as having a type provider in it, which with Visual Studio triggers all the permission stuff with. Does VS Code do that, or is it?
Yeah,
Okay, yeah, the F sharp IntelliSense on the generally does. At least doesn't mean it. So what you need is a type. It's going to be that's going to hold your type provider. Which takes a config and inherits type provider from namespaces, and new edition does that. So what we're actually doing here after this is defining our provided types. So this is obviously here because it's typed in, and then it's in an F# source code file is the type of the type provider. So that will actually appear in the type provider. That will actually appear in the type provider assembly, but you can't really use it. So what we're doing here is then defining the provided type, a provided type from the type provider, which is going to provide the types. So what we've done is we put it in namespace in a synthetic namespace FCK type provider, and we've called it FCK provider, and we've derived it from object because it's not going to do much. So that's the erasure trick there. So if you had your own, just because this is just to purely demonstrate some IntelliSense and do hello world, this is just derived from object. But if you had your actual runtime type, then that's probably where you would put it. At least the runtime type for your database connection. But that's the erasure bit is what you pass in there. It's not actually derivation. So then we define this create type method, which is going to take a parameter. It takes two here. So this one called tname is the type name, which in this scenario you just pass straight. In this scenario you just need to pass straight through. But what we have here is another parameter, which is what's going to be between the angle brackets on the type provider. So what we're then doing is generating a type which is provided by the type provider, which again is derived from object. We're extracting that. We're just getting this who parameter out, and we're putting a static property on that type, which uses the who parameter. So the property is called, interestingly, prop. It's string. It's static, and there's that getter code for the quotation, where we're passing in the who property here. And then we're calling add member, which adds a property member to that type, and then we're returning type back. Probably should write this bottom up. This is the thing. So what we're doing here is then defining the type type provider type. So we're saying that it has a static parameter. So that's what's going to go between the angle brackets. So we're passing it in there, and we're passing in that constructor function, which actually generates the type that the type provider is providing. And then we add it to the namespace, and it should work. Simple, right?
So on the getter code that you got found asks, what would be in the parser that in there?
So, well, in a getter unit, but it needs to be. You need to pass it in as that constructor anyway. It's just because yeah. So it's a unit method. So I'm going to run this type provider. I'll show you. Let's hope IntelliSense actually still bloody works. No, for fuck's sake. It seems to go awfully hot. Right, I'm just going to have to kill some windows. really exciting demonstration. So I'm just going to kill my editor. Yes. So it does actually work. It's my editor is being able. So to demonstrate that I haven't hard coded it.
Does the utility sense work?
Probably might. Okay, yeah, that's probably asking for actually. Yes. No, that doesn't actually. Might do. I don't think it does. But you know, if you weren't doing this in bloody Emacs, I'm running smart lights at work. So that's pretty much it. Has anyone got any questions?
So would it be fair to say that type providers are probably too clever by half?
Yeah. I think some of the existing ones do have utility, quite a lot of it, for some tasks, but yeah, they're much more of a shiny demonstration feature than they are necessarily day-to-day use. Certainly on something. I mean, because how many times do we access schemaless online data sources as part of our code?
Having thought quite handy for just hacking together scripts just to parse.
Yep.
Yeah, it strikes me that it fits into the sort of trying stuff out in the REPL kind of experimentation, just quickly dashing something out and trying rather than sitting there trying to work up a chunk of mapping code. Speaking as someone who had to deal with a database which was a table with columns like 50 columns wide, and spending an hour or two actually having to manually write all of that out, it would have been quite nice to have just hooked a type provider up and just go even for that first.
Yeah, this is a project for Excel provider.
So yeah, I mean that's where I've maybe successfully using this with horrible XML munging tasks and things like that, rather than say certainly web service access, which is what raising type providers originally targeted.
So just a kind of ad hoc script, basically.
Yeah. But they're I guess that depends what you mean by fun. They're interesting to write. But it's kind of an unpleasant API, unfortunately.
So is the performance good enough that you can use them if you haven't got a massive sort of data sets to sort of read them? Because you said they can write as well, did you?
Yes. So I mean that depends how you write them, I guess. So because of the erasure thing, you can generate whatever types you need within limits, because obviously they're .NET 1 types, and God knows if they support modern .NET features like span and stuff, possibly not. So assuming whatever you're doing is maybe something you can call external libraries and things. So,
Well, the idea of most quite often why you have data that's got CSVs quite often, it's missing columns and things like that, and just being able to put a value into that.
Yeah.
It's just a big batch, at least you know everything's then got the same number of columns, and you don't have to worry that it's reformed everything after that.
yeah, I guess that's how performance sensitive. I mean, that's some CSV processing can be terrifying.
But that could be a sort of an over 90 sort of thing.
Yeah, if it's that kind of thing, then the type safety around that's probably reasonable. I mean, there's libraries like Deedle and F# which are probably faster.
So I'm guessing they're not in any hurry to get it into .NET Core, since we just hit .NET Core 2 and they're still not there.
Mm-hmm. I'm not sure the amount of work that needs doing, but because you could, I mean, in theory, you could run the compile time type provider stuff in a different frame as when it generates. But yeah, there's a lot of competing priorities with making .NET Core make less people cry. I don't think they're porting WCF to it.
Yeah, my experience with F# and .NET Core has been everything's absolutely great until you just fall down an uncovered mountain unexpectedly out of the blue, and everything was going perfectly great. Oh wait, we're not quite ready. Maybe you're not able to use this in production after.
Yeah, not the best kind of surprise. But yeah, let's say that's just it's just really a symptom of a larger issue. I think some of the changes are actually quite small, but it's the F# team Microsoft is 5 or 6 people.
Yeah, it is quite small, isn't it?